that or anything, but I want you to think about this for a second, because we're all in kind of a more intense math class than just, hey, do this and it works. Look, if I wrote this down right here, x squared times y minus 9y, could you pull a GCF out?
Yeah, why?
Because I want to. All right, so you pull the y out, right? You pull the y out. Everyone agree with that?
Yep.
And you're left with x squared minus 9? Yes? So that's what you would do, right? That's exactly what we did here. We have a GCF, but the GCF isn't just a single thing. It's this whole factor. So this x minus 2 and x minus 2 gets pulled out, and this is really the x minus 2 now. And the x minus 2 times x squared minus 9 is the result. You see that? So it's not like, I just don't want you to think that it's just this step that doesn't have any process or thought to it.
That actually answers like another question I've always had, is why do we just put it, oh, well, those two things, x squared, instead of putting x minus 2, squared?
Yeah, I always thought that. I was like, why wouldn't you square that x minus 2?
This is why, because it's really just a GCF.
So
That's all it is.
I was just like, all my life.
That's cool, right? Does it make sense now?
Yeah.
If that makes sense, then it's been worth the time.
Oh, don't worry about it.
That's why. Now,
Don't worry about it. It just does.
so when I do it in my classes, if you were in my class when I was teaching, when I teach grouping, when I would have been here, my next line would have been these two the other way. Because that's the way I show them what it is. But we all know multiplication is commutative, so it doesn't matter which way you do it. And when people are trying to teach it to you without making you think about why, they just tell you to write these two down in parentheses and then just that, right? And that's kind of like the no thought way of doing it. If you actually GCF it, it's this flipped. But it doesn't matter because yeah. Okay. All right, let's keep going. Let's keep going. Sorry to distract you there. Now, we do want to go and factor everything completely. And it says here, x-intercepts, this step may require factoring. Maybe it's further down. I thought I had in there, I thought I had stressed in there, make sure you factored completely. This is not factored completely because x squared minus 9. So this is going to be x squared times x plus 3 times x minus 3 times x minus 2 equals 0.
X equals 0, x equals plus minus 3, x equals 2.
Yep, I'm going to write down all the x-intercepts off of these, right? So you just set each of these equal to 0. I get an x-intercept here of 0, x-intercept here of negative 3. Notice I'm just listing them out underneath, okay? I'm not going to go through the step of actually like setting it equal to 0 and solving.
I actually kind of did it the lazy way, and I just screwed around and put plus minus 3.
Yes, you could. But you mean from here and you didn't do this?
Yeah.
You're going to have to completely factor to determine your cross and touch, though. So just be careful with that. You'll see on my next step. Those are my 4 x-intercepts, aren't they? The question now is whether or not I touch or cross at each of those. So let's figure that out. Let's look at the multiplicities. What is the multiplicity of the factor that creates this 0? So you go back to its factor. What's its multiplicity? 2 even means touch. So I'm going to touch here. Okay, at negative 3, I go back to the factor it came from. What's the multiplicity? 1. That's an odd number. I'm going to cross. This 3 comes from this factor. The multiplicity of that factor is 1. I'm going to cross here. And then here, cross again. See, that's the part that I was saying be careful with. People will look at 2 and say 2 is even, and they'll say touch. It's not 2, it's the factor. It's the power on the factor. And with that information, that's all we need to sketch this polynomial. Even though I do ask you to find the y-intercept. So let's do the y-intercept since I asked for it. What's the y-intercept? Those are easy to do because all you have to do is plug in what? 0 to the function. So what's f of 0? In this particular example, because I don't have it up on the board anymore, it's 0, isn't it?
Yeah.
Okay. Yeah. Are there any questions?
How did you get the y-intercept again?
Plug 0 into the original function, but I don't have the function up on the board anymore.
Since there was nothing without, like...
There was no number by itself.
Yeah.
right? I think I do have it up here. Oh yeah, it is right here. Look, right there. There's your function. If you plug 0 into everything, 0. All right, step E, multiplicities. So I kind of already got this. Multiplicities, right? And then I'm going to plot the x-intercepts and the y-intercepts. Sketch the left and right-hand behavior, do all the multiplicity crossing stuff. Basically, the last few steps are just draw the graph. So here's the way I'll do it. I think I'll start with a fresh board here. There's my x and y axes. I'm going to plot my x-intercepts. So just make sure I get them here. 0, see -3, +3, and 2. Once I've done that, I go to my left and right behavior. Critical that you go to your left and right behavior now. Don't go try and do touch and bounce. Left to right behavior. So what is the left behavior of this polynomial function? It was, what was it? It was down on the left. So I'm just going to put, see this is the last x-intercept I have over here, right? I'm just going to put an arrow pointing down like this. And then on the right side, I go to my furthest point, and over here I'm just going to put an arrow going up like this. What's wrong? Yeah, it's either this or that or that or this. It's
one of the tutors told me to do John Travolta or something.
Really? They're helping out? Yeah. All right, so now we put it all together. Okay? I know that my graph must go down to the left. I know that this must be a smooth curve. It's not going to have any jumps or breaks. It's not going to have any jagged edges. I should be able to draw it nice and smooth and curved. When I'm moving and drawing to the left, I must go to this x-intercept and I must cross through there, which means I must pass through the x-axis. So I'm going to start doing that. Now, kind of tweak that a little bit. I'm going to come up and I'm going to cross through here. Now, let's start thinking ahead. Where have I got to go next? To 0, right? And when I've got to get there, I can't come back down, right? Because I would go through the x-axis. So I'm just going to go up, and when I get to the 0, I'm going to touch or bounce, however you want to look at it. So I'm just going to go like this, and I'm going to bounce off and come back up like that. And then I've got to get to the next x-intercept, which was 2. I forgot to put 2 there. And when I get to that one, I need to cross through. And things are getting kind of tight here, so I'm going to think this through. I'm going to come through here. I'm going to cross through. Then I've got to get back to this one and cross through there also, right? So it's going to go like that. If you do things correctly, you should meet your other side, which it works, right? There it is. That is our picture. That's the best we can do in college algebra. Now, you could go try and get more points if you wanted to. But if you said, I'm going to plug in -2 so I could get this point, there's no way you can tell me that's the highest point.
Without going through everything.
You would have to check every point in here to make sure, and that you don't have enough time. So you may draw that, then someone else on their test may draw this. Both of those answers are correct. All right, so everyone's picture may look a little different. And compare that to the real picture. There's the real picture, right? What's that?
Is that completely accurate?
That is the graph, yes. That is the graph. But look how high up they go.
Yeah.
Look at that. What this right here goes up like way almost up to like almost to 100, right? But that's what I said earlier. In this class, we don't mess with that. We don't mess with how high that goes. What we know from this picture is the left and right behavior. We know the x-intercepts. We know where the function is positive and negative.
How would you figure that out?
In calculus. Yes, that's what calculus is. Yeah.
Like, is there
There's a formula. It's the difference quotient. All you do is this. I don't want to stretch too far, but I'll just show you. You remember how we said the difference quotient? Geometrically, here's what the difference quotient was doing. You're picking a point, x, and then you're picking a second point, x plus h. And what you're doing is finding the slope between those 2 points, right? And I said that what we want to do in calculus is move this point right to that point, right? Like right on top of it. So we let h go to 0. And so it slides this point over. And what happens is this slope of this line actually becomes the slope of what we call a tangent line. So do you remember, like on the test? Let me see. Let's see if this person got this one right. Difference quotient 1. Who got the difference quotient right? Someone have it? Is number 4? Anyone get number 4 right? Here you go. On number 4,
I got it half right.
we had a difference quotient. Oh yeah, by the way, we're done with that. We graphed it. We're done, okay. On number 4, we got a difference quotient. The original function was 2x squared plus 3x minus 5. You got a difference quotient of 4x plus 2h plus 3, right? That's what you got. So, oops, sorry. So what you're saying here, okay, with this answer, is that if I want to find the slope of a tangent line, okay, if I want to find the slope of a tangent line, what I'm going to do is I'm going to let this point come to this point, so I'm going to let h go to 0. Let h go to 0 in this, and you get 4x plus 3. Do you agree? Okay, so now it's just a matter of what does this represent? It's the slope of a tangent line, right? Look at the highest point on that graph, that curve. Or for this one, it's the vertex, isn't it? What would the slope of the tangent line be up here?
4.
No, right here. If I were to draw a tangent line right here,
0.
What would its slope be? The slope, it would be a flat line, wouldn't it? That slope would be 0? Yes? So I bet you that this function is going to flatten out like this when the slope of the tangent line is 0. And that's the slope of the tangent line. So set it equal to 0. Set that to 0, and what do you get? Negative 3/4, right? So that means if I go out to my graph, and oh, that's the wrong side. Y-axis is over here. If this is 0, I go out this way, this negative 3/4, that's where it should happen, right? But watch. What's that special formula I gave you? Negative b over 2 times a, which is negative 3/4. This is where it actually comes from. It comes from this. This formula comes from this idea. Okay? That you can do for all quadratics. So here's what you'll do to find that point in calculus. You will set up the difference quotient on that nasty function. You see that nasty function right there? You set up the difference quotient on that. That's nasty, isn't it? Yeah. And then after you do that, you let h go to 0, and then whatever you get as your answer, you set that to 0, and you're in business. And that seems like a real pain in the ass, doesn't it?
Yeah. I can't even joke about that setting. That's horrible.
After you suffer for a while, because we make you suffer in Calculus 1, we make you suffer for just a while. Then what we do is this. Remember, this is the answer right here, right? Then we say, guess what, everyone? All that stuff we were just doing, there's a shortcut. Here's the shortcut. You see your original function?
Yeah.
See that 2?
Yeah.
Bring that 2 out in front and multiply. What would you get? 4. Now bring that power that was 2, bring it down by 1. And what would you get? 1. Okay, now you see here, this same thing. What's the power on x here? 1. Bring that 1 out front and multiply. What do you get? 3. And then now bring the power down. X to the 0 is 1. So this is just 3 times 1, which is 3. Okay, what's x to the 0? Bring the 0 down. 0 times negative 5?
0.
Oh, shit, that's the same thing. That's it. That's called the power rule for derivatives.
What?
You have to trust me. Look, if you like the shortcut, go take business cal, because that's what they do in business cal. They just give you the formulas. In calculus, you have to understand where they come from. You have to understand where those rules come from. So anyway, okay.
So basically, this is the end of cal. This is what you mean. We're not at the end of cal 1. We're getting cal.
It's like when we were doing the grouping,
Yeah.
we're just told to break the negative 2 minus down, but we weren't taught how. So that's like teaching us.
Yeah.
That's right. It's understanding what you're doing as opposed to just like monkey see, monkey do.
So basically, either is correct, but you were teaching us the more grammatically correct way, technically, for math.
What with the difference quotient?
For factoring earlier, like how you said that the one left in the parentheses both times should technically be on the left.
It doesn't have to be, but like if you're going to do it the way, if you're thinking through it, like you're factoring out a GCF, then your answer should look like x minus 2 in parentheses x squared minus 9. But if you're just doing something that you've been told, then who cares, right? All right, so here we go. Let's try a couple of these. We have about 15 minutes left. Let's see if we can do number. Yeah, I'll let you do one on your own, but let me at least lead you off with one of these first ones, because one of these first ones we haven't seen. I'll do number 2. F of x equals x minus 1 squared times x plus 3 squared. Now pay very close attention to what I'm about to do, because I have not given you one like this, right? I've actually given you something, we've had to factor it, right? We had to factor it. This is already factored for you, isn't it?
You have to divide it.
But you still have to figure the left and right hand behavior out.
So work in reverse.
Let's try this right here. If you were to multiply these things out, think through this. If you were to multiply x minus 1 times itself, what would the largest power of x be that you get?
X squared.
X squared. So this right here is really behaving like x squared, isn't it?
Yeah.
And then this right here, if you multiply this times itself,
X squared.
you're going to get another x squared as your highest power.
So they both together it's even.
Together, it's x to the 4th, isn't it?
Yes.
So together, what we can say is the degree of this should be 4,
Right.
without having to multiply it all out. Understand that? Further, the leading coefficient would be the number in front, positive 1. Because right, when you do this x, this is x times x, you get positive x squared. When you do x times x again, you get positive x squared. X squared times x squared gives you positive 1 x to the 4th. Right, so these two would be positive 1 x to the 4th. So leading coefficient 1, so the left up, right up, like that. Left and right sides go up. Even power, positive leading coefficient. Now the x-intercept step is the easiest step because it's already factored, right?
Yeah. Positive.
So set these equal to 0. So set x minus 1 squared, x plus 3 squared equal to 0. How many x-intercepts do I have?
X
Just
equals
2.
1,
Just 2, right?
X equals -3.
And negative 3, right? So 1 and negative 3? What about, right, set them each equal to 0. So set x minus 1 equal to 0, set x plus 3 equal to 0. What about multiplicity? What's the multiplicity going to tell us? They're both even, right? So touch, touch. Touch, touch at each of those. And that's all we need to draw it. So I'm ready to draw. Any questions?
Why didn't they teach most of this in high school?
So far, everything's pretty easy to draw because it's the factoring's kind of been nice. So I start with my x-intercepts, right? Put those first. Then what do I do after the x-intercept? The arrows, right? The left and right. And I'm just going to kind of go, all right, here's my point to the far left. I'm just kind of draw like this. And then over here, I'm just going to kind of draw like that. And let me see if my hand comes in here. Yeah,
Maybe we should
good
figure
enough.
if there's a Y-intercept.
Yeah, we didn't get the y-intercept. I really, honestly, I don't care if you get the y-intercept on these. Because again, there's so much we don't know about this graph, right? Like how high it goes, how low. that just having one extra point to me doesn't matter. But we can do it. Do y'all want to do y-intercept? Let's throw it in here. Here's the y-axis. What's the y-intercept? Not on this one. The y-intercept. What's f of 0? So you have to plug 0 into the original function. So it's 0 minus 1 squared, 0 plus 3 squared, which is 9. Right? This is 1 times 9.
So that would give us the height of the.
That means over here it's 9. I'm just going to put 9 here, okay? But there's nothing that says that's the highest point or anything. That's just a y-intercept.
Yeah, it kind of tells you, like, okay, where am I going to cross the line?
It does tell you that, yeah. So what am I going to do? From here, I've got to come down. And when I get to this one, I'm going to touch it or bounce off of it. Then I've got to come back up, go through this y-intercept, come back to here, touch it, go back up or bounce. So it'll look like this. Now I did something on purpose here. I went through the y-intercept, went up a little bit more, and then came down, because there's nothing that tells me that's the highest point. Now, if you make it the highest point on your graph, it's not wrong, okay? Because neither of us know if it is, right?
Because we're just sketching.
We're just sketching, right?
I mean, it
Again,
could go
that's a
higher.
calculus problem, how high that is.
I mean, it could go higher to the left of the way.
That's right. Let's see what it does.
That's how I do it.
I can do this quick. It's a 4th degree polynomial. It has a root of -3, another root of -3, a root of 1, and a root of 1 again. That's the graph right there.
Yes, I was right.
So you can see just by looking at this graph, whoa. There we go. That's good enough. You can see the y-intercept is not the highest point on this graph. In fact, it does something like this. The true graph comes up like this, then comes back down like that. Okay, but we're not going for that sort of precision here. Okay? All right, we've got about 9 minutes left. I'm not quite sure if that's enough time for you to get started, but how about... Why don't you see if you can do any of those?
Any of them?
Let's make that your homework assignment to be turned in next time. Okay, so forget what's on the schedule. Do those 6 problems, except skip 2, because I already did 2. Okay?
And do the rest.
Remember, those notes are online, right? You can get to those notes online.
Do the rest or just one?
You're going to turn that in for a grade for next class, okay? Sign in. You know what? Is Caleb here?
Yeah.
Okay. Then everyone who took the test is here, so I'm okay with that. Yeah, so if you want, you can start on this now. If you want to pack it up, you can go. If you want to talk to me about the test or something, I'll hang out.
Are you going to post the solution for the test online so I can?
Yeah.
That's a good idea. Let me send a reminder for myself to do that right now.
Because I think if I just go through that, I'll figure
Yeah.
it out.
Yeah, 'cause I like to go